everyone, welcome back to another video with Arduino. Today we're going to be building the second part of our project, this second servo motor head, which will control the angle that the ball will be released. So we're just going to go over how to control the servo motor using two buttons, and yeah, let's hop right in. The first thing you're going to want to do is make sure that you watch my previous tutorial with how to control the base part. So basically there are two buttons here that will control the wheel either clockwise or counterclockwise, and depending on which way I choose, this is clockwise, then counterclockwise, and it will turn whichever button I choose. So now we're going to be looking at this servo motor. You see here I already have it in its main form, and basically the servo motor will control the height. It will adjust depending on what the buttons choose, which buttons you press. So that's what we're going to be making today. So yeah, we're just going to look at how to connect the servo motor, connect it to the Arduino, connect this base. I'll teach you some of the dimensions for this cardboard base, which actually holds the servo motor in between, and then I'll go over the code on how to connect it using these two buttons. So now let's get into that. Okay, so I've attached the buttons now. One important thing to note is that these two buttons are going to connect to pin 4 and 5. This will also be shown in the wiring diagram in the next clip if you want to see that. But besides that, what you also need to do is connect this battery, because the servo and the servo motor and the stepper motor, those two, like they use a lot of power, and a simple Arduino cannot power it by itself. So we're going to need to connect this battery to this extension port right over here. So you can see I took my servo motor out from these two contraptions. You can see this is kind of like a triangular base. I just made this out of cardboard, and it holds the servo motor in this pocket right here. So when you are creating that, what I did was I just cut out a piece of cardboard, I guess 3 pieces, and then just folded them. Something important that I learned like through trial and error was that if you make this cardboard base too big, like if you like stack it up like up here and make it really bulky, the whole thing is just gonna flop over. So something like this, where it's light, it can stand by itself and hold a little hold an extension over here as well. That will probably work best. So here's the servo motor. In case you don't, just these are the dimensions. I would cut it out where this is. So you see, we want to create like a pocket here so that it fits in. So that is the dimensions for that. And then you would just cut a hole with the length of that length, and then this. And so you would just cut that out in a cardboard, and then you can stick it in. If you pull it, if you are able to just stick it in like this, then it fits through like this. We're going to go over this part as well, where to connect those. Just a heads up, I think it's ground 5 volt and pin 3, but you can see that in the wiring diagram. This part is more of just a long strip. You can choose however long you want to make it. I believe mine is pretty long, like 9 inches. Make sure you have one side and you poke it through just enough so that the servo head can fit inside of it. So that way you see a little peep there. And then if I take these two and I stick it through, it works. And then I can adjust accordingly. So we're going to go over the wiring diagram for both these parts, and then after that we'll assemble it. Sorry, I just want to preface this by saying I made something incorrect. The pin on the servo that's connected to the 3.3 volt currently right now is actually connected to the railing of the 5 volt. Okay, so here is the wiring diagram. I did not include the driver module just because it's not available, or it's not the exact one that I have. This is the one that it shows on Walkly, but I'm not familiar with what these options are. So these are the 4 button arrangements. The servo motor is attached here. You can see the different um, sections that it's connected to on the Arduino board. If you want to see the driver module being connected, I'll play a segment here and I'll link it to the video. Um, I'll link it to my previous video where I talk about how you can connect it. But besides that, this is what the wiring diagram looks like. And now we're going to hop into the code. Okay, so now we're just going to go over the code that was revised from last time we visited this. You see we have the servo.h library, which is important to communicate with the Arduino and the servo motor. We have these motor pins. We went over this last video. What I really want to show is this part. We have the button up and the button pin down connected to pin 4 and 5, and these will control the angle at which the servo motor lifts the cardboard funnel at. So we also have the servo pin equals 3. That was we connected the servo motor to pin 3, and this will essentially allow us to communicate with it and tell it what to do. Right over here, let's see where it references pin up and pin down. This one is the logic, so it reads it as it's up or down. Up means that the button is pressed, down means that the button is not pressed. And if the button is low or if the button is pressed, we want to increase the button slightly. We want to increase the position slightly. So we want to tilt it up higher, and we don't want it to exceed 180 degrees. So every single time we press this button, which is represented by low, then the servo position will increase by 10. And it is the opposite. Servo motor dot right just makes the servo motor to that angle, and this is the opposite, where if the second button is pressed, we want to decrease the position slightly, and we want to write the position so that the servo motor adjusts accurately. This is stepper control, which we went over it last time, and these two are the functions for the stepper motor. But that's essentially it. We just have the servo motor, which is controlled by 2 if statements, and if one button is pressed, it increases the angle, and another button pressed, it decreases the angle, minus equals 10. You can also change this to whatever you want. If you want to increase the position more, you can just do 50 or like 50 as well, and then change this angle limit to even greater, so that it can be fully upright and such. But yeah, that's essentially it. This is the code. I will be pasting this in the description, and feel free to drop any questions in the comments. So I'm going to put the device together one last time, and then we can see it in action and close off. All right, so one last final thing. Before you start running your code, make sure you have like a piece of tape or something, and you could just tape this in place so that it doesn't move. Something like that, just secure it down. Make sure you have this bottom piece and attach it here. You can tape it to this bottom piece. You can use duct tape, what I used before, and just be able to lower down. Okay, so that's going to be it for this video. If you have any questions, here are just some of the connections. Feel free to visit any of my previous videos to see how any of these different parts work. If you have any questions, make sure to leave them in the comments. After this is going to be the last video of the series on how to build this. for the code and Arduino. After this, we're going to be looking at how to build the board, but that is more miscellaneous and just kind of, you could be as creative as you want with it. But that's about it for this video. Make sure to stay tuned for the next video in the series so you can complete your very own Arduino Palooza game with this crane contraption. But that's about it. Make sure to like and subscribe if you really did enjoy, and